Hey guys, my name is Riley. And my name is Gerald.
Today, we will be presenting you our redox reactions project, which is metal recovery from ores, otherwise known as metal extraction.
Without further ado, let's dive into our redox reactions project, metal recovery from ores.
What is metal extraction? Before we learn how metal extractions are a form of redox reaction, we need to look at what it actually is. So let's look at what is being extracted, ores. Ores are any naturally occurring source of stone that you can extract metal from. There are many different types of ores, but a few common examples include aluminum, which is the most common metal in the Earth's crust, found in all kinds of minerals, which its ore form is bauxite, which contains 50 to 70% of aluminum oxide. Copper, which can be found in many types of ores like sulfide ores or chalcopyrite. In relation to chemistry, ores are commonly oxide sulfides like, for example, bauxite Al2O3, hematite Fe2O3, rutile TiO2, pyrite FeS2, chalcopyrite CuFeS2. Now let's look at what extracting metals from these ores mean. Metal extraction is the process of extracting metal ores buried deep underground, also called mining or metal recovery. The ores are found in the Earth's crust in a variety of amounts. The extraction of metals from ores is what enables us to use the minerals in the ground. Now let's look at ways metal can be extracted from ores. Processes of metal extraction. There are many ways metal can be extracted. A few methods include 1. Open pit mining. This is the most common technique. Soils and vegetation are first removed from the mine site. Ore is then extracted by blasting charges using special saws and drills to loosen the bedrock and remove the ore from the formation. The ore is then transferred to processing stations, which are massive industrial machinery used to extract and transfer the ore from the earth. Open pit mining is usually cheaper and safer than the alternatives, but it is environmentally unfriendly. 2. Underground mining. This is the more historical and usual way. Shafts are put into the ore deposit. Passages open off the shaft, and the ore then broken down and brought to the top. This process is usually done for vein deposits, where rich ore veins can cover great distances through the earth. Often the more cost-effective option in formations where a few metals, rich veins, or regions occur. 3. Fluid mining. A leaching solution is put into drill holes to dissolve metals, and then recovered, which will then have the metal separated from the solution. This approach is mostly for higher tier metals like gold and silver. Benefits of metal extraction. Metal extraction is an outstanding process. There are many ways it can benefit us. Here are just a few. Raw metal can be a source of income. It can be exported and sold to countries which use metal frequently, for example, China and America. It can provide employment for a large number of people, which results in more infrastructure, such as hospital and transportation networks being built. It can boost the economy of both the local community and the government through taxes. Here is a brief history of mining and metal extraction. The earliest known mine for a specific mineral is coal from southern Africa, appearing to have worked 40,000 to 20,000 years ago. But mining did not become a significant industry until 10,000 to 7,000 years ago. In early times, the only metals available were those found in a metallic state in nature. The most abundant was copper, gold, silver, and mercury. The application of fire to mined materials became a technological breakthrough and proved to be one of the critical advancements of civilization, which is in fact a redox reaction. This is created by elements that transform themselves by the application of heat. This will be covered later. Later on, metals could be melted and formed into objects. Nowadays, our world depends on metal extraction for a variety of reasons, such as technology, the benefit of the economy, and much more.
Next, let's look at how metal recovery from ores is a redox reaction by explaining how redox applies and is utilized in metal extraction. Explanation. Since metals are often found combined with oxygen as oxides, the oxygen must be removed by using carbon to obtain the metal. That process is done through redox. Specifically, we use redox reactions to get the metal we want by removing the oxygen using carbon mixed in with the ore to get the specific metal we want. Oxidation and reduction are used together as the electrons of the elements are transferred from one atom to another, and since there is both a loss and gain of electrons, which is the metal with oxygen being reduced and the carbon being oxidized, metal extraction classifies as a redox reaction. Now let's look at a few reactions and how each specific metal is extracted from the ore using redox. Example 1. Lead. The reaction below shows lead being extracted from lead oxide. As you can see, carbon is being used to extract some metals from their metal oxides, and this is a displacement reaction, which is a type of redox reaction, and occurs because carbon is more reactive than lead. In this reaction, the lead oxide is reduced, which is the oxidizing agent in this reaction, while the carbon is oxidized, which is the reducing agent. Example 2. Zinc. This reaction shows zinc oxide reacting with carbon using a furnace to get zinc and carbon monoxide. As you can see below, this is also a displacement reaction, which is a type of redox reaction, and happens because carbon is more reactive than zinc. In this reaction, the zinc oxide is being reduced, which is the oxidizing agent, and the carbon is being oxidized, which is the reducing agent. In detail, carbon displaces the zinc atom, causing the zinc-oxygen bond to break while a new carbon-oxygen bond forms, therefore forming zinc and carbon monoxide. Example 3. Iron. Finally, let's look in complete detail at how iron is extracted from an iron ore. This process is commonly done via a huge container called a blast furnace. In detail, iron ores such as hematite contain iron oxide, and the oxygen must be removed from the iron oxide in order to leave the iron behind. Since carbon is more reactive than iron, it can displace iron from iron oxide. Here is the process of the blast furnace extracting iron shown via redox reactions. Step 1. Oxygen reacts with the carbon to produce carbon dioxide and heat energy to heat up the furnace. Step 2. More carbon is added to the furnace and reduces the carbon dioxide into carbon monoxide, which is a good reducing agent. And finally, step 3. Iron oxide is reduced. In this reaction, the iron oxide is reduced to iron, which is the oxidizing agent, and the carbon is oxidized to carbon dioxide, which is the reducing agent. In further detail, when you mix the carbon with the iron oxide, they use the carbon to take the oxygen out of iron oxide, so that the end result is iron by itself and carbon with oxygen. Here are the examples shown in more detail. Conclusion.
A metal just doesn't come in pure form. Most of the time it must be extracted through ores, which is metal mixed with oxygen, known as oxide. 2. Various processes, benefits, and a history of metal extraction. 3. Metal recovery is a redox reaction, specifically a displacement reaction, that uses carbon to remove the oxygen from the specific metal being extracted. 4. This is explained by the fact that in order to extract a metal from an ore, you need to use carbon as a reducing agent, and the metal mixed with oxygen as an oxidizing agent to obtain the metal you want from an ore. And last but not least, the examples we used to illustrate the statement were through the process of obtaining the metals lead, zinc, and iron through a blast furnace.
Thank you for watching, and have a nice day.